Welcome back again to our class. This is Mrs. Teresita V. Moreno. Welcome to our physical science class. So today we'll be talking about concept of atomic number that led to the synthesis of new elements in the laboratory. So these are the objectives. Explain how the concept of atomic number led to the synthesis of new elements in the laboratory. Second, identify the different elements formed after the process of synthesis and realize the importance of the atomic number in identifying the new element's identity in the periodic table. So for your pre-assessment, you can scan the QR code with your phone camera or any gadget you have. If you are using laptop or PC, you can just connect to the URL given or the link given so that you can upload the the game proper or the quiz proper. So this is to gauge how far you have ideas with the topic that we'll be discussing for today. Okay? So you can post this one and answer it first. Then you can check right away your scores. Okay, in our previous discussion, we were talking about the Big Bang Theory stages. So accordingly, there are three stages. First is the singularity. So when you talk about singularity, this is a one-dimensional point. Okay, wherein which contains huge mass in infinitesimal space, where density and gravity become infinite and space-time curves infinitely. So where laws of physics, as we know today, is also operating. Then the second one is the nucleosynthesis. What do you mean by this? There is nuclear fusion and the formation of new nuclei actions in an early stages of development of the universe. And the last one is the recombination. So recombination is the formation of the capture of free electrons by the cations in plasma. Okay? So in our activity, activity 1.1, that is on page 35 of your modules, making your own periodic table. So you have here the instructions. You follow the instructions, and then you may come up with your own periodic table. So the instruction or the direction is make your own periodic table using the hypothetical elements that are given with the clues. Explain the words or word that will be formed if you arrange symbols of the elements correctly. So you have letter A, P and PR both are 1 electron each. PR has a bigger atomic size. Then letter B, OD, RI, and E are in the same series as P, C, and I. In terms of atomic size, P is the biggest, while C is the smallest. E is a metal, while I is a non-metal. OD is smaller than RI in atomic size. And letter C, O has a bigger atomic size than E. In the same group, Y is also bigger atom than C in the same group. R is more non-metallic than Pe, but more metallic than Ti or titanium. Then you can check your work on the using the answer key of your manual. Okay. So we will be discussing about the history of atomic structure, who are the people behind, how this atomic number led to the discovery of new elements. So to start with, Democritus in 460 and 370 BC. So he develops an idea of atoms. So during his time, he doesn't name it atoms, but instead he gave a name atoma, which is indivisible. When I say indivisible, that cannot be seen with our naked eye, and you could not found it smaller than that. Okay, next we have John Dalton. So what would be the contribution of John Dalton in the atomic history? Okay, he suggested that all matter was made up of tiny spheres that were able to bounce around with perfect elasticity and called them atoms. So it was John Dalton who gave the name atoms instead of atoma. Why? Because according to him, it is more perfect to give a description atoms, since all matters contains with tiny spheres that bounce back or that are bouncing. So that is very elastic in nature. Then another person who made in the history is Joseph John Thomson. That is in 1898. So what was his contribution? He found out that atoms sometimes eject a far smaller negative particles called an electrons. And as of today, we use electrons as the negatively charged particles in an atom. So where can we find electrons? Usually they are found in the outer shell of the element or the atom. So he also used this structure like a plum pudding in the plum pudding model, where the electrons are the negatively charged particles. Another person is the name of Ernest Rutherford in 1910. So what was his contribution? He identified that there is nuclei inside the atom. So what he used is his model using a foil. So using a foil model to identify that there is the presence of nucleus. And the nucleus now is identified as the protons and the neutrons inside the nucleus. Okay, where the protons are the positively charged, while the neutron is the neutral charge. That makes up the atomic mass. Okay, next is Niels Bohr. Okay, what was his contribution? His contribution is that he refined Rutherford's idea. Since according to Rutherford, electrons are the negatively charged. So according to him, according to Niels Bohr, electrons are in orbit around or orbiting around the atoms. So this is the model used by by Niels Bohr. So as you can see in the diagram, there is the example is bromine. Bromine is, I guess, atomic number 35. Yes, it's atomic number 35. Okay, that's why if it fills up the fourth energy level. Now, if you observe in the given diagram, we have different, we have 7 energy level, and that comprises the period, the number of period in the periodic table. So you have period 1 is the first energy level, period 2 is the second energy level, period 3 the third energy level, fourth, fifth, and sixth. And in this example also, you can see that the electrons occupies the SPDF level. So how do you know that this is 35? In the first shell, there are 2. In the second shell, there are 8. So 2, 4, 6, 8. In the third shell, 2, 4, 6, 8, 10, 12, 14, 16, 18. And the fourth shell, you have 2, 4, 6, and 7. Now, if you notice, the outer shell contains 7 electrons. That would signify that bromine found in group number 7A. So that's the number of the valence electron. Before we move on, S can occupy, we have the SPDF pattern in the electron configurations. So S can accommodate 2 electrons, P can accommodate up to 6 electrons, and D is 10, then F is 14. Now, another person also involved in the history is Henry Gwen Jeffries Moseley, or we usually hear that name, Henry Moseley. So what was his contribution? Okay, he contributed to, or he demonstrated that atomic number of protons in an atom determines most of the properties of an element. So, okay, since the protons are the positively charged. So, relationship between atomic number and the charge of the atomic nucleus. That was his contribution. And another person is James Chadwick in 1932. So what was his contribution? He is the first person to discover that neutron, as previously an unknown neutral particle, produced along with carbon 12. 12 is the atomic mass by nuclear reaction between beryllium has a mass number of 9 and helium has a mass number of 4. Okay, and he is the first person to synthesize elements that does not occur naturally on Earth. Example is technetium. Okay. And the last one is Dmitry Mendeleev. Okay, what was his great contribution? He is the founder or made the classification of elements that we use today as we know as the modern periodic table of elements. Okay. Now, okay, this is the elements, the periodic table of elements. I hope you are familiar with the periodic table of elements. Now, we have here, as you can see, there are numbers 1, 2, 3, 4, 5, 6, and 7. And we call that one as period. Now, we have here group 1A, group 2A. This is group 3, group 4, 5, 6, 7, and 8. We call that one as the group. Okay. Now, in your periodic table, it is color coded. So, colors will signify what type of element they are. Whether they are alkali earth metals, alkaline earth metals, other metals, transition metals, the lanthanides, the actinides, whether they are metalloids, non-metals, the halogens, and the noble gas, and even the unknown elements. Now, looking at your periodic table, you have there the symbol, of course. Like in this example, we have iron, Fe. That's the chemical symbol. Below is the name, and below the name there is an electron configuration. Above is the atomic mass, and some periodic table, it contains the ionization energy. Some also includes the electronegativity and the atomic number. Okay, sometimes it also includes the oxidation state. So It depends on the periodic table that you are using. So titingnan nyo na lang. You examine very carefully the periodic table, the key information written in your periodic table. Okay, sometimes the electronegativity is written below, just like in the periodic table that I am using. So the electronegativity is found in the lower part. Okay. So you must check carefully if you have your periodic table. So ibig sabihin, hindi lahat ng periodic table ay pari-pariha ang format. Now, you can see also below the electron configuration block. You have there the S block, the D block, the F block, T block, and yun. You have only the SPDF patterns. So, I hope you are familiar with the electron configurations. In some periodic table, the electron configuration pattern is also given. This one. Okay, you have there the SPDF pattern. Okay. Below your periodic table, there are some polyatomic ions, the anions and cations are also given here as the examples. Dito. So, you can use this especially in writing chemical formula and in naming some chemicals. So, what about the atomic structure? So, this is how the atomic structure looks like. Okay. So, this is the electron found in the orbit as mentioned by Niels Bohr. Then you have here the neutron, the blue one. That's the neutral charge. And then you have there the protons, the red one. These are the positively charged particles. And the protons and neutrons comprises the atomic mass, or the mass number. So mass number is different from atomic number. Remember that. Okay. Then we have the shell or the orbital. So this is how we use the atomic structure. For example, the given element is helium. What is written on top is the atomic number. Okay. You can see in your periodic table, they are arranged based on the atomic number. This is the number of protons in an atom also. Then 4 is the atomic mass or the atomic weight in other periodic table. So do not be confused. When I say atomic number, it is also equivalent to the number of protons. When I say atomic mass or atomic weight in some periodic table, this comprises the number of protons and neutrons in an atom. So it says here that the number of electrons is equal to the number of protons. In short, your atomic number is also equivalent to the number of electrons equal to the number of protons. I hope you are familiar with the subatomic particles. Okay. So anyway, I'll be posting video lessons or tutorials on how to identify the subatomic particles of an atom or subatomic particles of some elements. Then how to write electron configurations and identify the valence electrons, and how do we write chemical formula and read chemical formulas. Now going back to the Big Bang nucleosynthesis. So accordingly, the oldest stars in the galaxy are deficient in elements heavier than helium. So another statement would tell that the current record holder has iron and hydrogen about 130,000 times smaller than the solar value. So not quite down to Big Bang abundances, but we are getting pretty close and still looking forward. So what are the chemical present in the universe? So there are three stages accordingly. First is the chemical evolution. So how does chemical evolution happens? There is low mass stars synthesize new helium, carbon, oxygen during main sequence of RGB, the HB and the AGB phases. So these newly produced elements are brought to the surface via convection and redistributed via stellar winds and planetary nebulae into the stellar medium to be incorporated into later generations of stars. Okay, the second one is the chemical evolution 2. So this is for massive stars. There is equilibrium fusion reactions, produce elements all the way up to iron. And these freshly made elements are delivered via stellar winds or sometimes more spectacularly via supernova explosions. And the last one is the chemical evolution 3. Okay. Maybe you are familiar with transition metals. Okay, example is transition elements. Example is iron or the Fe. Okay, equilibrium fusion reactions of like elements don't proceed past iron because of iron's location at the peak of the curve of binding energy. But accordingly, in certain circumstances where supernova, for example, non-equilibrium reactions can build elements beyond Fe in the periodic table, many of these elements are usually radioactive in nature, and sometimes they are stable elements. Now, what about the neutron capture elements? Okay, this neutron capture elements has two principles that they are following: the S process and the R process. So the S process is the slow addition of neutrons, and the R process is the rapid addition of neutrons. So when I say S process or the slow process, um, uh, basically there is a slow addition of neutrons or neutrons in the nuclei. So in addition of no produces heavier isotopes of particular elements, but they can emit electrons cold in the beta decay. The nucleus moves one step up in the periodic table. So as you can see in the structure, so you have most of the elements here are isotopes. You have silver, cadmium, indium. Sn is tin. Is that tin or antimony? Sn. Um, Sn is tin, and then Sb is antimony. And then you have here the R process. So there is rapid addition of nuclei, of neutrons in the nuclei. So rapid means here that many neutrons are added before the beta decay occurs. So first build up a very heavy isotope, then as beta decays occur. So you march up in atomic number and produce the really heavy metals. Um, for the activity on page 43 of your physical science module, you will be working with write the nuclear reactions involved in the synthesis of each of the following new elements. Okay, letter A is curium, symbol is Cm, that is 96. Okay, was formed by reacting Pu. Okay, Pu plutonium 239 with alpha particles, and helium. It has a half-life of 162 days. Letter B, mendelevium. That is atomic. It is atomic number 101. Okay. So was formed by reacting indium, En. 253. Where's that? Okay, you can check that one using your periodic table. With alpha particles. And letter C, meitnerium. Meitnerium. So the symbol is Mt. That's 109. Okay, was formed by cold fusion, which involves the combination of Bi and iron. Bi is bismuth. Yes. Bi is bismuth and Fe is iron nuclides at ordinary temperature. So you can do research on this, how this new elements is being synthesized using nuclear reactions. Then, what I have learned, why do scientists study and synthesize neutron uranium elements in the laboratory? What are the uses of these elements? So you can also search what's the purpose, what's the uses of this new synthesized new elements. Then create timeline using illustrations and text showing how elements form with the concept of atomic number. For your post-assessment, you can scan the QR code again using your phone camera and then download the apps. If you are using the laptop or PC, for Android, you can use the QR code. So we are using physical science, LDM, as our references, pages 25 to 50. I hope you learned something with regards to the objectives that we are talking about for this day. I hope you can now explain what's the importance of atomic number in the synthesizing of new elements in the laboratory and what are their uses. And then I hope you can also identify now the different elements formed after the process of synthesis and able to realize the importance of the atomic number in identifying elements, identity, in the periodic table. So, hope to see you guys. Thank you for listening and keep safe, everyone. Have a blessed day. Once again, this is Mrs. Teresita V. Moreno.